Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Let's continue our journey. Mechanics, dynamics, second law of motion, and we're still working with friction that we started recently. And let's continue with friction, but now friction on the incline. It was friction on the flat surface, nothing changes. Static or kinetic friction. And we have a body, and this is alpha. And we have mu, and we have m, and we have alpha. And we need to know the friction, the acceleration, the usual stuff. So, as always, start with forces. We have this force, which is mg. And mg is result of communication, interacting, use your word, of this body with the earth. It's called gravity. Then, of course, as before, we have normal reaction. This incline, this surface, it provides a reaction up, normal, perpendicular to itself, and exactly as before. Only in this case, when we have friction, there is also F friction. Exactly like on the flat surface, and F friction goes along the surface, perpendicular to N, and those two projections give us some kind of total reaction of the surface to the body. But nobody is interested in this. We're always happy to have normal reaction and friction, which is along the surface. And those two together describe us how the body reacts and how it communicates and how it interacts with this surface and the body. And as always, we write the second law of motion like that. It's always the same, it's universal, it's the genius of this guy, Isaac Newton. And now we put it here, F friction, and you see it doesn't matter where I start. I started with the first thing I see. The order is absolutely irrelevant. And I put all the vectors and I say MA. All the forces equal MA. Nobody knows how to solve vector, well, we know, but it's too complicated. It's much easier to deal when we have a coordinate system. And when we saw, we can choose coordinate systems the way we want, but as we saw previously, it's much easier to put the x along the surface and y perpendicular. And then we have two projections. Projection along x. We have mg, and so again I would draw this picture like before, mg and this alpha. This is alpha because this angle and this angle, they are the same. Why are the same? Because this side of this angle is perpendicular to that side of this angle, and this side of this angle is perpendicular to that side of this same of this second angle. So sides are perpendicular to each other, there is only one way, angle is the same, so we have triangle, this is hypotenuse, this is alpha, this is mg sine alpha. Don't know that? Read my, and this is mg cosine alpha. Two sides. Don't know this, don't fluid in this, watch my clip, mathematic prerequisites, trigonometry, vectors, talk enough about this. You have to be fluid by now to see this triangular, to see this hypotenuse, to see this alpha, and immediately say that this is mg sine alpha, this multiplied by sine. So friction, I put F friction minus F friction. And notice I don't specify what friction is. I want to write mu n, but I don't, because it's too early, because I don't know what kind of friction I'm experiencing here, static or kinetic. So minus F friction, n is 0, because x is this way, n is this way, projection of n on x is 0. plus mg. mg goes down, projection goes this direction, and projection, as we know, it is this mg sine alpha. Equal ma. Of course, if the body moves at all, it's a. It may be not moving. If it's moving this way because it's going down. It may be a equals 0. It means that body is standing still or moving with a constant speed. It's the same. Y, F friction equals 0 this way, and Y is that way, projection is 0, N is N. Goes this way, and it's the full. Mg goes down, this projection comes with negative sign, and it will be mg cosine alpha. And it is 0 because the body can move only along the incline, it cannot go inside the incline. So the projection of A on this axis is 0, A is parallel to X, so projection on Y is 0, so we have this. And let's try to be a little bit more compact. We have F friction equal mg, mg sine alpha minus, let's deal like this. Let's say ma equal mg sine alpha minus F friction. Well, it's pretty obvious what's going on here. Mg sine alpha tries to put the body in this direction, but it's compensated somewhat or completely by a friction. So the net of those two forces acting along this axis is mg sine alpha minus F friction, and it's ma. It's a second law of motion and projection on x-axis. One force tries to push it, another resists. It's exactly like it was on the flat surface. And second equation, n equal mg cosine alpha. And basically that's all we need to know. Then we put n, we find n, and then we say that F friction max equals mu n equals mu mg cosine alpha. Right? And from here we have two choices. If mg sine alpha is greater than mu, I will wipe it out. And so I know F free max, and so I have ma equal mg sine alpha minus F friction. And so there are situations that's very simple. It's so happen that mg sine alpha is very small. For example, the angle is very small. We just slightly tilted this incline. Then it's compensated by a friction. A equals 0, mg sine alpha equal F friction, and all we have to check that F friction is less than F friction max. We have to check that mg sine alpha is less than this value, mu mg cosine alpha. If this is the case, if alpha is very small, this is very small, this is like almost 0, and cosine when alpha is very small is 1. So if this value is very small, then we're standing still, we have static thing, A equals 0 and F friction, and I put here friction max actually, is less than F friction max. So, F friction less than F friction max, that means that this is static. And if friction max is mu n, that means it's kinetic. So A equals 0 and friction is less than friction max. And here A greater 0, but friction is maximum, it's mu n. And this is the case when A equals 0, so this is a static case scenario. But if we increase the alpha, we will have 0 greater than, A is greater than 0, that means this is greater than this, that means F friction is less than mg sine alpha, and that means that F friction is mu mg cosine alpha is less than mg sine alpha. And I leave it at that. I let it think. So you understand that if alpha is very small, we in static case scenario. Because on the flat surface there is no force in this direction, the body doesn't even want to go that way or that way, it's flat, and there is no friction, we add a little bit incline, then there is a little bit mg sine alpha that wants to push the body down, give it acceleration, but friction is enough to compensate for this, and when we put in a very big angle, then this is almost mg sine alpha is almost mg, like at 90 degrees it would be mg. And friction becomes very small, because first of all we overcome mu n, but then there is also cosine alpha, because n becomes smaller and smaller as we increase it, and friction becomes smaller and smaller. And I leave it for now, and I talk about this a little bit more, quite a bit more, in my next problem. So, not to mix it, don't forget to subscribe and bell. And like, of course, like, you're always welcome to like, you're always welcome to put a comment. Thank you.